Hi, good afternoon. Now I will introduce Lab 4, which is in Newton's second law. Okay, then the first thing we are going to do is we are going to visit the home page for this lab. These two files, I intentionally hide them. These are my work. I will share with you my work, of course, but I will not, keep these files so that they will not be copies like for you. Okay, now this is my home page where I have the rubric, and of course we don't have a minimum work. This is online, and this is the submission. Is going to take you to Gradescope where you're going to submit. This lab will not be due until Tuesday 22nd, because 21st is going to be a holiday and 20 also is going to be a holiday. Then this is planned to be a little bit different. Pay attention to when you should submit. All right, now, okay, this is really here the page that I'm gonna maybe have in the instructions. All right, but one thing that I want you here, that is really the video. It's gonna tell you like the video is unavailable. The reason is I think it's protected by the university, the MIT, but you can watch it on YouTube. Okay, then just I have the link and we will watch this together. Okay, then basically this is just Atwood machine. Okay, Atwood machine, basically it is just like this. Okay, two masses, that one of them is going to be heavier than the other, and then the system is going to be accelerating based on the difference between the two masses. Okay, we will cover this in the lecture. Okay, but also here I'm asking you, because this is based on what we did study in chapters 4 and 5, derive the equation used to calculate the acceleration of the system using Newton's second law. And this is the equation that I'm asking you to derive. Okay, then you should show a derivation. This lab is going to be a formal lab report. You should submit two files, the Excel file and the Word document that is containing your lab report. After the data, you are going to have a section, it said pre-lab activity, where you are going to show me the derivation for the equation. Now, the procedure here, this is actually a brief description on how the actual experiment is going to be performed, very similar to what like the professor did in the video. Now we are going to have here, of course, the length of the string is not really important, but we add in it so that based on the tables that we're going to use in our labs. But I'm gonna have 500 grams on each end of the string. Now, when I have 500 here, 500 here, ideally, because I'm considering no friction, nothing, then I will say they're gonna balance. Then they should be at the same level. The system will not accelerate. I'm adding here a statement. Don't forget to include the hanger's mass in your calculation. And make also a small effort to use the same amount of tape on each hanger if you want to make them stable. Now, adjust the apparatus so that the bottom of the falling object is exactly 1 meter above the ground. This is going to be my y for the calculation that we are going to do down, below. Okay, then what this y is going to be 1 meter. Now add 5 to one side and be sure that the falling weight will reach the floor before the rising weight strikes the pulley, so that the system is going to work nicely. At the instant you kick the meter stick support from under the weight hanger, start the timer and stop the timer when the hanger strikes the floor. Record the time in the data table. Of course, we are going to be very fortunate if we're going to have a timer like you did see in the in the video, but of course for us we're going to do this manually. Add additional 5 grams for the total mass of 10 and repeat step 6. Then you're gonna repeat adding 5 every time and record the time that is needed. And complete all the other attempts. Record the time needed by the heavier mass to reach the floor in the table provided. Your data section in your lab report will include only data given and measurements, no calculated quantities, because here we're going to have so many calculated. Then don't mix calculated with data. Okay, now for the calculation of the theoretical acceleration, we are going to insert a table that included the following calculated quantities: total mass, F net, and the acceleration. This acceleration, we called it the theoretical, and we're going to calculate the theoretical using that following equation. Okay, this is all is going to be done in Excel. Now, there is another calculation which is going to be for the experimental acceleration, and where I'm going to calculate A experimental using 2y divided by t squared, and we're going to record also the value in the table below. I did not add it here, of course, the table, because I have it on Excel. Remember that y is the initial height of mass 2, and calculate the absolute difference, which is like just the difference between the two. You're going to add another column and another column also for the percent difference. You're going to graph also A experimental versus A mass added divided by the total mass, and you are going to use that graph to calculate G, which is the acceleration due gravity. And then finally, you are going to calculate the percent uncertainty in G if the theoretical value of G is 9.80 meters per second squared. Now, here is the data that is provided, okay, for these like 17 points. And now I'm going to share with you my Excel file where I did that work here. This is actually here where I listed all my added. Then we said we're going to add 5 each time. Then it's going to be 5, 10, 15, 20, 25, 30. I would not show you how I did my calculations and the functions, because now you should know how to do this. Now, this is going to be the mass on the left, and this is the mass on the right. Actually, these are 550, 550, but I'm going to add to the left, I'm going to add the 5 grams so that the left is going to be heavier, and then is going to start making the system acceleration. M here is going to be the total of these 3 masses. Then you're going to add here 5 plus 550 plus 550. Now, this is my conversion. I converted my numbers into kilograms, because when I deal with the newtons, usually I should have that in kilograms. Now, okay, I want you here to keep 2 decimals, 2 decimals, 2 decimals, 2 decimals. Here also 2 decimals. Now, for the force here, this is going to be the difference between the 2 masses times G. And of course, it's going to be that mass here. It should be in kilograms, because this is the difference between the 2 masses, which is the mass added. And you're going to convert this into kilograms, and then multiply by 9.8 to calculate what is really the force here. Now this one here, it is my theoretical. Okay, then let me do that. Okay, your titles, everything should be very similar to what I have in here. Subscripts. Okay, then this is my A theoretical. All right, and let me have these in bold. Okay. Okay, now this is the time that was provided by my data. I calculated here t squared, and then here I calculated A experimental. That one is gonna be 2 times y. Y is 1 meter divided by t squared. And you can look here and see like my numbers are almost like close to each other. Okay, then if you compare this one with this one, because you're gonna add another column for the difference, for the percent difference, for the absolute difference, and then for the percent difference. Of course, remember here in the Excel sheet, we're gonna have a mix between the data points and the calculation, but in your actual lab report, this should be divided. Now here I added another column, which is going to be M added divided by the total mass, and that is gonna be because I want a graph, and this is my graph. Okay, this is my graph. I should move my graph to a new sheet. I should label my axes here, the x-axis and the y-axis, and the x-axis, and also having a title for my lab. Okay, then here for my graph, then here I should have for the y, I should have a label and a unit, and for that one also a label as a unit, and also I should have a title, and you're gonna insert that equation on the graph. You are going to use that formula to calculate g, which is the acceleration due gravity, and finally you will have the percent difference also calculated. Of course, you're gonna list your results under results section, and that's it for this lab. Thank you and have a great day.